Database architecture and automatic storage management. In this nugget, we're going to start with just a little bit of review in order to make sure that we have the fundamentals down. As I told you in the introductory nugget to this series, we are formally assuming that you have Oracle Certified Administrator level experience with Oracle Database 11g. Nonetheless, the inclusion of database architecture in the DBA2 exam objectives leads us to this conclusion. We need to review the difference between the database itself and the Oracle 11g instance. This is a distinction that you'd be surprised to learn how many Oracle administrators remain fuzzy on. We need to be crystal clear on that distinction. We also need to be crystal clear on the differentiation between the logical and physical components of Oracle Database 11g. First of all, reviewing what the terms logical and physical mean, and then of course applying those terms to Oracle Database and its various and sundry files, processes, memory structures, and objects. Then we're going to spend at least half of our time learning about automatic storage management, or ASM. ASM is a really cool way to store your database files. It's one of many features of Oracle that to me makes Oracle Database the premier relational database management system. I like to look at it like this. In terms of different RDBMSs, you have ones that are really small and not very feature-rich. Maybe you can look at those as, say, a Yugo, if you remember the old Yugo car from the 80s. I'm actually having a hard time thinking of a comparison to a car nowadays. Maybe an entry-level Honda Civic? I don't know. On the other hand, you have really rich and robust RDBMSs like Oracle Database that I look at them either as something like a Ferrari, ultra performance, or something, if we want to stay with Honda, a Honda Odyssey van, which is really like a space shuttle. It has so many bells and whistles. It has rear backup cameras. It has sensors all over the frame of the car. Just absolutely loaded with features. And that, I think you'll agree with me, is very descriptive of how Oracle behaves. There's a feature for just about everything. And by the end of this nugget series, you'll be familiar with most of them. Let's get to work. Our first piece in our terminology review is differentiating between the Oracle Database 11g instance and the database itself. This has been a long-standing comparison-contrast exercise with Oracle, and it tends to be confusing for those who come from another RDBMS platform, in particular something like Microsoft SQL Server. Now then, let's take a look on the first column here and understand about the Oracle Database 11g instance. The textbook definition of the instance, friends, is a collection of memory structures and background processes that support a single database. Now, in comparison to something like SQL Server, where an instance is an installed copy of a SQL Server engine, like the database engine, and then within that instance you can have theoretically an unlimited number of databases. In Oracle, that's fundamentally different. We have a one-to-one correspondence between the instance and the database. The instance provides the boundary and framework for the database. As you see here, the database in Oracle terminology refers to the actual file system objects in the database. We're not talking about logical objects like tables and stored procedures. We're instead talking about operating system level files. Things like the data files that in turn ultimately contain the data and the schema and the structures of your database. The control file, which is a very small binary file that contains key metadata without which the database won't open. For instance, the control file contains the location of the data files, the location of the online redo log files, as well as information related to checkpointing, the system control number or system change number of the database. Control file is a tiny but extremely important file in the database. The online redo log files are crucial to data recovery. We're going to be working with so-called ORLFs all throughout this training because, as you already know, a large part of the DBA2 exam objectives center on disaster recovery. And the redo log file is a file that contains a record of all changes that have been made to the database. Thus, when it comes to data recovery and being able to replay or roll forward, or to use the term itself, redo past committed transactions, those online redo log files are crucial to support this point-in-time recovery. Now then, back to the instance level. I mentioned that the database instance refers to memory structures. Now, you'll find in Oracle, this is again one of the hot rod features of Oracle that makes it stand apart from its competition, is that Oracle architecture allocates memory for many, many different processes. The three main processes in memory are the system global area called the SGA, the program global area called PGA, and the user global area or UGA. Now there's going to be one system global area per instance. There's going to be multiple PGAs. Basically, a PGA is going to correspond to each of your background processes, which we'll talk about in just a moment. And we'll also typically have more than one user global area because each user session, each connected session to the database will have its own allocated memory area. Now, if you're thinking to yourself, Tim, that's a lot of memory potentially, you're absolutely right. Therefore, it's good to have lots of memory on your Oracle database servers. Number two, you might be thinking, well, Tim, do we have to size each of these memory pools individually? That's a lot of overhead. The answer to that is if you're a glutton for punishment or a control freak, yes, you can individually size, but automatic memory management in Oracle 11g enables you to set an upper level threshold, and Oracle will in turn allocate RAM to each of these memory structures in the division or correspondence that it sees fit from moment to moment. That tends to be a smarter choice under most cases. We talk about memory management in the DBA1 course, by the way. Specifically, the shared global area or system global area, as I said, is instant-wide. To be sure, there's no better source for really useful illustrations than Oracle's own documentation library. I'm going to be referring to the Oracle documentation quite a bit throughout this training because anybody who's anybody in the Oracle world is very familiar with it. It should be your first stop for documentation helps. Tahiti.oracle.com should be bookmarked on all of your web browsers. This is the root level link to the Oracle documentation library. You can search across the entire library here as you see, or we can dip into specific releases of Oracle. For instance, we have release-specific documentation. Oracle 11g Release 2 is the version that the exam is based on. And if we go in there, we can furthermore, again, search across all the books at this release level, or we can open up specific books in HTML format and render them right in the browser, or look or download the PDF file. Another thing that I absolutely love about Oracle documentation is if you view the HTML version of a book, in most cases you can then download that book not only in Adobe PDF, which I already mentioned, but MobiPocket or EPUB formats. This means you can load this document, side-loaded is the technical term, on an Adobe Kindle or a Barnes & Noble Nook device, or an iPad for that matter. iPad will read at least PDF and EPUB all day long. Now then, coming back to the page that I originally was at, this is a really nice diagram that shows the relationship between the instance and related memory structures. Remember I mentioned the system global area is a 1 per instance deal, and in turn what the SGA does is contain a bunch of additional memory areas. You have a shared memory pool, what's called a large pool, Java pool, streams pool. We're not going to explain all of that because I covered all of that material in the DBA1 course. What I will point out is the database buffer cache and the redo log buffer, because those memory pools have particularly important roles to play in terms of writing changes to your data files. That's what the database buffer cache does. Your requests for block changes, any change, let's say an employee issues SQL to the server that updates someone's salary ID or salary tier. Well, that transaction will be held in memory for a brief period of time, specifically in the database buffer cache, and then a process called the database writer is responsible for making the changes happen in the actual data file. Similarly, the redo log buffer is keeping track of every one of those changes that's actually taking place in the database buffer cache and recording those changes into a separate file, the redo log file, for use in the case of a disaster recovery scenario. All right, so we see now that memory structures are a core part of the instance. Background processes are simply background programs. It's executable code that runs as a service in Windows or as a daemon in Linux, Mac OS X environments, And these background processes have different roles to play. CHPT is the checkpoint process, LGWR is the log writer process, ARC is the archiver process. There's a whole bunch of these processes in Oracle. Again, I'm sounding a little bit like a broken record, but we formally define those as part of the DBA1 skill set, so I won't say too much more about those now. In the upcoming demo, I'll demonstrate how we can view their run status in the operating system. But for now, let's come back over and see if we missed anything. By way of review, I mentioned that the database terminology refers to the OS level files, data files, control files, and online redo log files. There's some other logical elements to the database, things like table spaces, segments. We'll talk about those momentarily. Now let's turn our attention to the other half of our terminology background review, and that's the difference between logical and physical components in Oracle Database 11g. First of all, the difference between logical and physical. I know I made the same analogy in the DBA1 course, but it really works well, so I'm going to make it again here. For those of you who have interest or experience with computer hardware, you know what a network interface card is, right? It's a card, let's say PCI card, that fits onto the logic board or motherboard of your computer and provides network connectivity to that device. Now that network interface card has what's called a media access control address burned, quote unquote, or permanently encoded in the firmware of that network interface card. We call the MAC address a physical identifier for that NIC because presumably that address is permanent and unchanging. Thus, when we speak of physical components in a general sense, we're talking about, if not physical, at least permanent or unchanging characteristics of an object. On the other hand, something logical is something that's assigned ad hoc and can be changed at any time and or with minimal effort. In our example of the NIC, we can bind one or more IP addresses or Internet Protocol addresses to that network interface card, and depending upon what our DHCP lease settings are, it's feasible that this NIC could be assigned multiple IPs over the course of a month or a year, you see? Now, taking that root level definition set, let's apply it to Oracle 11g. The difference between logical and physical in Oracle deals with whether the objects under consideration have a direct presence in the file system. Now, you remember what we did in the previous whiteboard when we talked about the database, that the database refers to the physical OS level files, like the data files, the control files, and the online redo log files. As you see, we've pretty much covered all of the physical components of Oracle Database. Now, we can break down data files a little bit more granularly. There's three types of data files, actually. There's your honest-to-goodness data files that contain user or system data. There's your undo files that contain your undo information. You'll remember that undo refers to the ability to store previous data and keep that on hand at least temporarily for the purposes of not only recovery, but also for read consistency. So we have user A coming into an employees table and making a bunch of changes, let's say making a bunch of updates. Well, what about the other employees who are running selects against that table? We can't have them see intermediate data. That violates some of the core principles of the relational database. Thus, we store the previous information in those rows in the undo table space in an undo file, and those folks who are running selects against that data see the rows as they existed at the start of their query. And then when the user who's in there making updates commits, then subsequent select statements that hit that table will only then show the changed data. You see? Third type of data file is the temp file, and temp storage is the same in Oracle as it is in the operating system. It's simply scratch space. So if we understand that physical objects in Oracle Database are ones that have a presence in the file system, what are the logical elements that do not show up in the file system or in the host operating system? There we're dealing with terms like table space, segment, extent, and data block. Now I put these in an order of pretty much broadest to most granular. Kind of if I were to do it with a triangle, it would look like this, working downwards, for a reason. The table space, again, is something that can confuse folks who come from other platforms. If you're a Microsoft SQL Server DBA, think of an Oracle table space in the same way that you might think of a file group. It's the same basic idea. A table space is a logical entity that is comprised or composed of one or more data files. It's a way to draw a logical boundary around your data files. Now remember, your data files may be spread across multiple disks. That doesn't matter to the table space at all. Remember, with the table space, we're concerned about logical organization. And why are we concerned about logical organization? Because we can assign access permissions to a table space that immediately cascades to any data files that are associated with that table space. You also see here very nicely the interplay between the logical components of the database and the physical ones. That is to say, the table space can consist of one or more data files. Now within the table space you have what are called segments. Segments have a one-to-one correspondence with a discrete object. When we think object at this level, just keep it simple. Let's just talk about tables and indexes. A single table we create is going to be represented logically in Oracle as a segment. And that segment, well, I actually have a better picture of this. Let's go back out onto the web and look at this couple tables I'll show you from the Oracle documentation. This first one shows the relationship, again, between logical and physical storage. On the logical side, it shows us the table space, which again is a logical organization of files. The table space is not a folder in the file system. You would never see it in the Finder on the Mac or Windows Explorer on Windows. You'd never see it there, but you can interact with table spaces all day long using SQL or using really any of the Oracle management tools. But the table space has a one-to-many relationship with data files on the physical side. Now, working our way down within the table space, I mentioned that a segment represents a single table or an index. That segment, even more granularly, is composed of what are called extents. Extents are composed of multiple Oracle data blocks. And then finally, we have another one-to-many correspondence from the logical side to the physical side, because an Oracle data block is composed of one or more operating system block. Now, an OS block in Windows terminology is referred to as a cluster. Chances are, dollars to donuts, you have your file system as NTFS in the Windows world, and those allocation units or clusters get turned into, by Oracle, one or more data blocks. And you can customize and do performance tuning to match those block sizes up, or to make the Oracle data block an even multiple of OS blocks and so forth. The second drawing I wanted to show you is this one. This is really nice. This shows you right off the top that you have individual data blocks, in this example of 2 kilobytes per size. This is the most atomic level of storage in Oracle. Now, those Oracle data blocks are not allocated individually. That would be extremely inefficient. Instead, you have what are called extents. An extent is a block of blocks, if that makes sense. In these examples, we have different size extents. As an administrator, we have control over how big or small we want our extents to be. But when Oracle allocates space for a segment, for an object, if we were doing a create table statement, let's say, we would have an initial extent or a number of extents allocated to that segment. So as far as Oracle is concerned, the extent is its fundamental unit of storage. Now I want you to see here that an extent cannot span data files. We mentioned that a table space certainly can comprise more than one data file. An extent must be located within a single data file. A segment, by contrast, can span data files. I hope that makes sense. What is ASM? At the beginning of this nugget, I drew a kind of cumbersome analogy that I semi-regret making. I hope it makes sense. Between Oracle's competitors as lower-level cars, maybe less feature-rich vehicles, and Oracle being a super-duper deluxe supercar with all of these bells and whistles. Now, I don't mean to overstate this, but things like ASM and automatic memory management are so thoughtful, in my opinion, of Oracle to give us as administrators. Let's face it, as database administrators, we're really busy people with lots of plates to spin. It's nice that we can offload some administrative responsibility to Oracle itself. And that's actually what we're doing with ASM. Formally defined, automatic storage management is a free pack-in logical volume manager, or LVM. You'll often hear ASM referred to as LVM, and yes, these are examples of TLAs, three-letter acronyms. Now, what the heck is a logical volume manager? We have the logical word coming back to haunt us, and we also have a volume. Now, what does this mean? Logical means ASM makes it so we don't have to micromanage our disk storage. We can create what's called an ASM disk group, and we don't have to care or worry about the specific drives that undergird that disk group, okay? Now, a volume in storage terminology typically or normally refers to as a formatted disk partition. You might have an ATA hard drive. Let's say we have a serial ATA or SCSI hard drive, and typically when we prepare that drive for use, we create perhaps one or more partitions for whatever reason, and then within a partition we format or initialize the partition, which gives it a file system of some kind. And in Windows you wind up with a drive letter. In Linux, Unix, and Mac OS X you wind up with a root file system, and you go from there. Now, ASM works kinda on that level. We're not concerned with formatting drives. And matter of fact, we cannot format a drive when we prepare it for ASM. Instead, ASM uses what's called a raw disk, a disk that has not been formatted with a specific file system. But the notion of the volume as a usable part of a disk comes into play because when we create these disk groups, we essentially throw volumes at ASM. We tell ASM, okay, we've got these 6 disks here, and these disks could be physically installed in the chassis of the server, or we could be talking about storage area networking LUNs. Whatever the case may be, there's lots of flexibility in the source of your disk volumes. But once you assign those disks and make them part of your disk group, then your storage just points to the disk group ID. And behind the scene, Oracle takes care of doing really cool things like disk striping, redundant array of inexpensive disks, or RAID, and also something we'll talk about more in a bit called balancing. Isn't that great? So that's what a logical volume manager does. It's meant to take a lot of the complexity out of disk storage and also give us some really nice gee whiz features like I just mentioned down here. You'll recall that striping refers to, instead of doing multiple writes on a single volume, we can in one pass write bits of data across multiple disks simultaneously, which gives us a huge performance benefit. You simply have parallel processing taking place. Similarly, with RAID levels, actually striping is a RAID level. It's RAID level 0. We have RAID 1 or disk mirroring. That is built into automatic storage management. Automatic storage management can work in conjunction with a drive cage you may have that's already set up for RAID 1 or RAID 5. It's very flexible in terms of its implementation. The balancing piece means you have this pool of disks. If you need to pull out one or more disk members for maintenance, or maybe you've determined that it's a bad disk altogether, or maybe in a worst case scenario there's a disk failure, you can remove that disk and then automatically ASM will rebalance the data such that any data that was contained on that missing disk gets stored somewhere else. In other words, there's a built-in redundancy in automatic storage management. As far as what you do in Oracle, how it looks and how you work with it, ASM presents a layer of abstraction between your physical storage and the database. Now, ASM is a huge topic. Here's the good news. In this nugget and for the purposes of your exam success, you only need to know basically what I've told you here and a few details on how to implement ASM. But this is not an ASM test, and you'll remember from the introductory nugget, ASM is mentioned in only one of all of the bullet points on the exam outline. So if you're thinking to yourself, okay, now what should be my time split between studying, say, ASM versus using the RMAN utility? I would say it's 95% RMAN and 5% ASM. So please keep that in mind as we work forward. ASM, the exam, and you. Now, one common issue that we candidates have as we prepare for certification exams is exactly which version of the software are we going to be tested against. Now, that can have some big implications. For instance, in the Microsoft world, those of you who are studying for the Microsoft Certified IT Professional in Windows Server 2008 were unpleasantly surprised a couple years ago when they walked into their exam and found a bunch of questions dealing with Windows Server 2008 R2 updates. Well, Microsoft was never very open about that, unfortunately. They just started slipstreaming new questions into the pool. Parenthetically, I'll say that my colleague James Conrad and I have addressed this in the CBT Nuggets library, and we do have full coverage for those R2 updates. Now, how does that impact us as Oracle candidates? Well, Oracle, fortunately, is really above board in that kind of thing. As you see down below, I've taken a screen capture from the Oracle Administration 2 exam page that we looked at earlier in the course, and I wanted to highlight a couple points down here under the training and preparation section. You'll see that the official training course that Oracle made for this exam is called Oracle Database 11G Administration Workshop 2 DBA Release 2. And then you'll see down below, it says that the exam has been validated against Oracle Database 11G Release 2 version 112010. Don't worry about the specific version number over here. What we're concerned with is this piece, in particular, the Release 2. Now, without getting too far into it, basically a release, Microsoft does it, Oracle does it, is a way for you to receive new updates and new features to an operating system or an enterprise application like Oracle without having to pay for an additional license. So if you already have Oracle 11GR1, you shouldn't have to pay to go to Release 2. That's normally what's happening. Whereas if you talk about a major version change, maybe Oracle 10G to Oracle 11G, that's considered to be a much more substantial upgrade, and you'll need to pay the appropriate licensing costs. All that is theoretical, though, but what is not theoretical and is eminently practical is that the implementation steps for putting ASM in your infrastructure are in fact version dependent, and the specific steps for installing ASM in Oracle 10G or even 11GR1 is different from what we have with 11GR2. So this has potentially big ramifications for us in our studying. Specifically, with 11GR1 and earlier, you could install an ASM instance by running the Database Configuration Assistant, or DBCA GUI tool. Very easy to do. The first page of the DBCA asks you if you want to set up or administer a database, or if you want to configure automatic storage management. That's all well and good, but that doesn't exist in 11GR2. With R2, you actually have to download a separate application and install that. It's called Oracle 11G Grid Infrastructure. I'm going to show you this in the upcoming demo, so don't get too freaked out about it now. But what this is a separate instance of Oracle, and that's really what's happening when you install ASM. In a standalone server environment, in other words, we're not dealing with Oracle clusterware and RAC, real application clustering. We're dealing with individual standalone servers. You're going to wind up having an instance for your database. That's all well and good. And if you want to use ASM storage, you actually install grid infrastructure, which creates a smaller footprint instance, no database, but just the instance, which we know are memory structures and background processes that support ASM. And those instances live side by side on the server. Yes, we're talking about potentially a large memory footprint. ASM doesn't have anywhere near the resource intensivity that a very busy transaction processing database will have, though. But sure enough, ASM does require a separate instance. And I think it's for that reason that Oracle logically took the installation of ASM out of the DBCA, which already assumes that you have an instance installed, and instead makes it part of your grid infrastructure installation. But no, black and white truth, that you do in fact have to download and install grid imp first, and then install Oracle Database. And one of the steps when you create your database in Oracle Database OUI is that you point the installer to your disk group instead of just the local file system, which is normally what happens. A little bit more now about the ASM architecture. First is just a repeat of what I told you, that ASM is installed as a separate instance as part of the Oracle 11G grid infrastructure. What I haven't told you really explicitly, but I'll do so now, is that you do not have to be working in a shared disk clustering arrangement to make use of grid infrastructure in ASM. That is to say, ASM works just as well in a standalone environment as it does in RAC. Now, RAC and clustering is not part of the OCP exam objective, so we're not going to be dealing with those subjects in this course. But basically what you've got going on with Oracle Clusterware and RAC is a high availability solution such that we have multiple nodes of the Oracle software installed on separate boxes. These could be blade servers or actual full-fledged rack computer chassis that are in some way connected to shared disk storage where your database files live. So you've got separate instances of Oracle database and potentially ASM running on each of your cluster nodes, and the physical database files, including control files and redo log files, are on a shared disk. And the idea here is we advertise the entire cluster under a single host name and single IP. So our middle tier applications, our users, whoever is accessing the cluster does so under a single name and IP address, and they don't know that we actually have a multi-node high availability cluster happening in the background. They don't need to know. Thus, if we remove one or more boxes out of the rotation for maintenance or upgrade or some other reason, the cluster still stands. See, it's a really important way to do business if you have, say, service level agreements that require that your Oracle database be up 24/7. In the upcoming demo, I'm going to show you ASM setup in a standalone situation, and that is the scenario that you'll be tested on the exam. As I mentioned, ASM is a separate instance, but does not include a database and does not use a data dictionary. So immediately you might be thinking, well, how are users authenticated to the ASM instance? They use a password file. Normally user accounts are stored in the data dictionary, but ASM doesn't have one, so Oracle uses a low-tech password file for that reason. And also you'll remember that we have the sysdba role that grants super user privilege to the sys account by default. Well, Oracle must have received specific feedback from ASM users in enterprise, namely claiming we need a sub-administrative role or at least a separation of duties between the sysdba and folks who are going to just administer an ASM instance. So you'll find that in ASM instance, there's a sysASM role that grants a user the ability to have super user privileges to ASM, but not to anything else. With respect to background processes, these are just two. RBAL and ARB are just simply two of several background processes that are specific to ASM. And I think you can see the BAL for balance and RB for rebalance speaks to what I mentioned earlier. Namely, if you have a mirrored disk group, you can remove a disk or have a disk fail, and ASM will grab that redundant data from the other set in the mirror pair and balance or rebalance that data across all other members in the disk group that still are online so that the disk group continues to function. Now, of course, if you're going to mirror a disk group, that's going to reduce your storage. If you create, let's say, a 20 gigabyte disk group and you mirror it, that's going to require another 20 gigs of storage on some additional disks, isn't it? So without mirroring, you may have 40 gigs of storage, but after you create the mirror, only 20. That's common sense. That should come as no surprise to anybody. So I mentioned that you have different levels of availability. You have ability to customize your mirror, your RAID situation. And like I said earlier, if you're using hardware RAID that's outside of ASM, you can actually have ASM basically bypass any internal load balancing or mirroring and just rely upon your disk subsystem to do that. The data is always striped though, and you have control as a ASM administrator over the size of the allocation units. And that's just going to depend upon your throughput needs. So you've got a disk group that contains a bunch of members. You can stripe really big. Coarsely is the official term that Oracle uses, using 1 megabyte chunks, or you can use really finely grained striping and set it down to 128 kilobytes. Again, it's just going to depend upon your tuning needs and your performance needs in the database. Some final notes before we jump into the demo. There are two main situations where we need the recovery manager or RMAN utility. Number one, we cannot use operating system utilities to back up ASM disks. We couldn't use the built-in backup tool in Windows Server 2008, for instance. The reason for that is I alluded to earlier the fact that we're not using a known file system, that is, a file system that current operating systems can work with. As a matter of fact, ASM, besides being a logical volume manager, is sometimes referred to as a file system in its own right, although we view the disks as raw disks using our operating system utilities. So because of that, we can't back up using operating system utilities. The disk partitions just look like they contain garbage as far as the OS is concerned. You also can't drill into the contents of a disk group using operating system utilities. It's kind of like trying to open the Windows registry by double left clicking one of those registry DAT files in Notepad. You're just not going to get there from here. A second situation that RMAN is important in use for, actually it's necessary to use, is when you're migrating data from traditional standard file storage into an ASM disk group. You need RMAN for that. And of course, it's presumed correctly that RMAN understands how to interact with the ASM file system. Now you might be asking, well Tim, that sounds pretty loaded. That proposition sounds pretty loaded that so much of this storage architecture relies upon, say, RMAN. Well, RMAN, we know, is not a file editor. It's a backup and restore tool. What if we need to crack into those raw partitions and get to the files that are in there directly? Do we have a path to do that? And the answer to that question, fortunately, is yes. There's a utility that Oracle gives us in ASM as part of the ASM install, called appropriately enough ASM CMD. And this functions in very much a Linuxy way with Linuxy type commands and gives us a command line entry into ASM disk groups. Final point, and you'll see this in the demo, disk groups are traditionally indicated with a short name and a plus sign in front of it. So if you're seeing some bit of SQL, whether it's creating a data file or mirroring a control file or whatever, and you're specifying a path, heck, it could be formatting an RMAN backup command, you can direct that content to a disk group by supplying the disk group name only with a plus sign in front of it, and that's enough to let Oracle know you're talking about an ASM disk group. And then you also, when you use ASM, you don't have to worry about file naming because Oracle will automatically pop in Oracle Managed Files Notation, also called OMF. We talk about OMF formally in the DBA1 course, but OMF is a way to offload and not have to worry about file naming conventions and just let Oracle take care of it. OMF does have a method to its madness, but if you're just walking up to a new Oracle instance with not too much background, you'll wonder, now how the heck did Oracle come at this name for this file? It looks wacky as all get out. Now without any further ado, let's get into the demo. Alrighty then. In this demo, I'm going to teach you how to install Automatic Storage Management, or ASM, under Oracle Database 11G Release 2. Now remember, as I talked about in the whiteboard portion of this nugget, the procedure for setting up ASM differs even within Oracle 11G, depending upon whether you're on Release 1 or Release 2. And because, as we also saw earlier in the training, that the certification exam deals with R2, that is in fact the procedure that we'll work with here. Now, the first thing we need to do is set up our physical disks, or our candidate disks for ASM. Now, I'm obviously on Windows. The procedure here is going to be a little bit different depending upon your host operating system. In Windows, we can open the Disk Management Microsoft Management Console. I like to do that from the command line wherever possible. We can open a run prompt as I just did and type disk mgmt.msc to open up that built-in MMC console. And I've attached not one, not two, but 3 disks to this server, and as you see here, Disk Management in Windows has become aware of those disks and is asking me for what partition style we want. Well, I'm going to choose the old school, the old trusty master boot record here, and we also need to be sure not to do anything with the file system. We want to make sure we create volumes, but we don't format them with a file system, and we certainly don't want to attach a drive letter to each one of these. We're going to leave them raw, as it were. error. So to get this set up quickly, I'm going to right click anywhere inside my disk 1 and just create a new simple volume and step through this wizard. I'm going to accept the defaults, but there are a couple important changes here. We're not going to assign a drive letter or drive path, and we're also not going to format the volume. Remember, that's important. This is just going to be a raw initialized basic disk. We'll now do the same thing for disk 2 and disk 3. Create a new simple volume using all the space, no drive letter, no format. Finish, and you notice that the disk management console displays these drives as raw without any file system. So we've set up our disk subsystem. I'm not going to format any disks here, as we've already talked about. And because we've not laid down a file system or done a drive mapping, or a drive letter mapping, I should say, you note that those disks do not show up in my computer. That's just fine. Now, to do ASM is going to require that we download and install the Oracle Grid infrastructure. So therefore, what you want to do is just run a Google search for download Oracle 11G, and you'll come to this page, which is the download page, or the overview page specifically, for Oracle Database 11G Release 2. We'll come over to Downloads. We have to accept the license agreement before we can download anything. You'll also need to create an Oracle Technology Network free account. We'll select our operating system. In this case, I'm on Windows x64. You don't want to download these two files unless you don't already have the database. If you want the grid infrastructure, we'll click See All, and we'll download this separate item here, the Oracle Database 11G Release 2 Grid Infrastructure for your host operating system. You see, it's about the size of a recordable CD, about 700 megabytes. I've already downloaded both the grid infrastructure and the database, and I've extracted those files to my desktop. So to install grid infrastructure, I'm going to right-click setup.exe and run this with elevated privileges. Now, if you've gone through the DBA1 training that I've done for CBT Nuggets, you know how to install the database. Installing grid is pretty much the same thing. We're using the Java Oracle Universal Installer. So the steps here are going to be exactly the same. Actually, the dialog boxes will be exactly the same regardless of your operating system. Really, the only difference is going to be how you structure or address your disks and directories. Forward slashes versus backslashes, the use of drive letters or not. The first question we get here is what we want to do. We can install and configure grid for a cluster or for a standalone server. We can upgrade the grid infrastructure or just install the software only. Well, we're going to choose the second option. This is not going to be part of a cluster, but instead going to be a standalone installation. And we'll click Next to continue. It defaulted to my language of choice, English, so I'll click Next here. Now it's asking us for specific information on our candidate disks. This is important here. It asks us for a disk group name. You'll want to change this so it makes sense to you. You'll note that the default name for our first disk group is data, and we're also asked to select from one of three redundancy models as we talked about earlier. There's high, normal, and external. External is if we're using an external RAID, external redundancy. We can use the software-based high redundancy built into Oracle Grid, or we can just choose normal, which is what I'm going to do here. Now, before we bring in our three disks, we have to ask ourselves, well, why aren't the disks showing up in this list here? And the reason for that is we haven't yet stamped those disks for use by Oracle Grid Infrastructure and ASM. Now, stamping is the process where Oracle essentially puts its mark on those disks. In fact, when we click Stamp Disk, it fires up ASM tool. The interface here says that we're going to step through the process of configuring new disks for the disk group, and in Windows, these disks must be stamped with this tool or the command version. Of course, in Linux, you'll probably use the command version. We'll click Next, and we see here that we have three disks that need to be stamped, these candidate devices, and we already know that these are the three disks that I just initialized. We're going to generate stamps using the prefix of the ASM disk group data. That's fine. I'm holding down Shift as I select each one of these candidate devices, and once we make a selection, conclusion, the next button becomes available. We'll click next. We can edit the metadata if we want to just by clicking in those link names. Note that it takes the default Oracle SID, ORCL. You'd want to change that if your database has a different name. I'm going to leave it alone in this case. Disk, and then the name of your ASM group, and then a unique ordinal number. I'm going to leave all that alone and click Finish. And now you'll see that we have disks visible, and we can choose one or all of these for participation in the disk group. Well, I want all of them involved, so I'm going to select all of them, and then we'll click Next to continue. Now you'll remember that we have a separate set of accounts, a separate sys account, a separate privilege level called sysadm, and for Simple Network Management Protocol, we have an ASM SNMP, I always get SNMP confused in terms of pronouncing it with the Simple Mail Transfer Protocol, SMTP. Try saying that 5 times quickly, right? Well, best practice in a production environment is to set separate passwords for each. I'm going to instead use the same password for both accounts and then click Next to continue. It's asking us for a base location. This is our Oracle base environment variable, and by default it's going to take the system drive, app, and then the currently logged on user. Now Oracle recommends creating a separate user account, traditionally named Oracle, to own the installation files. I'm okay with being administrator here. So this is going to be my Oracle base, and then we have the Oracle home location for the Oracle grid infrastructure, which is underneath Oracle base under product, and then the version number, and then grid. That's just fine. We're going to use the Oracle naming convention and let that go. Next, you see we're going to be running prerequisite checks to make sure that we're okay from a hardware and software perspective for continuing that installation. If we pass our prerequisite checks, which I hope that you will, and you do, we get a summary screen where we can save our output as an answer file or as in a response file to make this easier to rerun this in the future. Alternatively, we can click Finish and then actually run through the installation process proper. And we can see exactly what's happening each step of the way, both from a phase standpoint down below and specifically what's happening at any given point in time by looking at the status bar and what's being echoed beneath it. What we want to see at the end of the grid infrastructure installation is this, a simple notice that tells us that the installation was successful. So at this point we'll click Close, verify that we have some start menu options for that Oracle home, which we do, and we're going to launch right into creating the database and the Oracle instance, and we're going to use ASM as our repository for our first database. So I'm just going to quickly go through this installation of Oracle 11G Release 2. We cover this step by step in an exhaustive detail, you guessed it, in the DBA1 training. And then finally we come to the centerpiece. The reason why I'm running this installation is to show you where we can point the database to our ASM instance. Now you see our choices are to store the database, the data files, either in the traditional file system or by using an ASM disk group. This isn't available, of course, if we don't have an ASM disk group. I do though, and we're asked for the password of the ASM SMTP user, which we specified earlier. Let me provide that now. And we'll click Next to continue. Now, because we specified ASM as our target for our disk files, we're now asked, well, what disk group do you want? We created a disk group called Data. Its size on my computer is 61 gigs. You'll remember we had 3 members in our ASM disk group, each one sized at 20 gigs. Now, you're going to lose available space if you choose another redundancy level, but I'm not using redundancy in this example, as we already know. Now, at the end of this process, just by way of review, we're going to have how many instances of Oracle on this server? The answer to that is 2. We're going to have an instance for ASM, and we're also creating an instance right now that will be associated with our ORCL sample database. And at the conclusion of that instance database creation process, we see a plethora of message boxes, don't we? This one we want to pay attention to, this one in front, that gives us our key metadata. First of all, the location of the installation log file. We then have our global and SIDS for the Oracle database itself, and then our SP file that's stored plus data. That is the way we address our disk group. Our disk group is plus data, and the instance is plus ASM. More on that in just a moment. And then it gives us our database control URL. I'm going to quickly dip down to password management to make sure our key accounts are unlocked, of course, which they are. And in case I want to use some other ones, like Scott, I can unlock the account and supply a password to it immediately. All right, click OK, and we are in business. Let's click close to close out of here, and let's see what we've got going on, shall we? To test this, why don't we log into ASM-CMD. This is our command line interface to managing ASM disk groups. Remember that because these disk groups involve raw storage, we're not going to be able to just dip into those disks in my computer or whatever command or graphical file manager you've got going on is. You see, if I double left click on one of those disks, I get a not accessible error. Now, be aware that you're going to have to set the Oracle Home and Oracle SID values properly to shift your focus to the ASM instance before you're able to get into ASM-CMD. First of all, note that I'm setting Oracle Home temporarily to my grid directory under App Administrator Product 1120 because that refers, of course, to the instance address of the ASM. And then we're then focusing our service name, Oracle SID, to plus ASM, which is the default name of the ASM instance. We then can run ASM-CMD to get into that shell environment and run commands. We can use a question mark or we can use the help command to get a run of available commands in this environment. Let me maximize my window. You see, we can run a lot of commands that are similar, if not exactly the same purpose as what we find in Linux, Unix environments. Actually, there's a couple nods to commands that also work in Windows, of course, like CD for change directory. There's no dir, unfortunately, but there is ls to do a directory listing. You can create folders, you can remove folders, you can manage quite a bit of properties in the ASM group while you're in this environment. So as you see, I ran an ls to go to the top of my disk group. I CD'd or changed directory into there, ran another ls, and then we go inside. We've got storage for ASM and ORCL, control file, data file, online log. It's laid out pretty darn reasonably, and that syntax is all part of OMF or Oracle Managed Files. Really helpful stuff. Now there's a lot to this. If you're interested in going much further, for the purposes of the exam, you really know everything you need to know about configuring ASM at this point, but certainly consult the Oracle documentation and read their syntax help for ASM-CMD if you're so interested. We're going to revisit the subject of ASM throughout the course because as we take our backups, of course, we can point those backups not only to a location in the file system, but we can also specify our ASM disk group as well. Now this second folder on my start menu refers to the Oracle Home, and I just want to quickly fire up the database control tool before we end this particular demo. I'm going to authenticate here as the sys user using the sysdba privilege. That's par for the course here. Once we're in OEM, we can verify we're connected to the ORCL instance. After all, these changes I made in this session to Oracle Home and Oracle SID are going to disappear as soon as I close this session. Those were session level environment variables. In database control, we'll come on over to the server tab, and I just want to show you a couple spots where we can reference or work with the ASM disk groups. Over here in storage, this is going to be a very rich area for us. I'm going to go to data files here, and let's take a look at our data file list for this ORCL freshly created database. And of course, you see plus data that references our ASM disk group, and then within there, as we saw in the command line, the ORCL folder, and then the data file subfolder, and then finally you get to the Oracle Managed Files. Now when you create a new object, like creating a new data file, you're going to see that our storage type can always now be switched back and forth depending upon automatic storage management enablement, if enablement is a word, I believe it is, or if you prefer the file system. Now we have only one disk disk group created data, so that's all that's available here. If we switch this over to the file system, the page will refresh, and we can simply manually provide a file name, manually provide a file directory, and manually assign a table space and file size. Good deal. Let's come back to the home page. The other main tab that we're concerned with in this course is availability, and we'll visit where we've been before, the recovery settings. In particular, we'll come down to the flash or fast recovery area, and you'll see that the database configuration assistant makes some presumptive guesses on your part. Namely, it assumes you do in fact want a flash recovery area, and it chooses whatever your default storage location was, whether that was file system or whether it was the disk group. And as you see here, it is in fact using our ASM disk group. If you want to override that, choose a different flash recovery area, you can, as I started to, using the flashlight to authenticate as an OS administrator and then browse and find it. So those are the basic introductory components to working with ASM in Oracle 11g Release 2. In this demonstration, we'll take a look at investigating memory structures, process structures, and storage structures in Oracle Database 11g. We can do this pretty quickly from an SQL prompt. I'm actually going to kill the session I had active in my previous session, and we're just going to start a new command prompt session. We'll log into SQL Plus as the sys user using the sysdba privilege. There we go. And we'll begin by looking at some memory structures here, live and in person. First, I want to hit a $V view, a dynamic performance view called SGA Dynamic Components. Now we can always run the describe command to get a run of the columns contained in a particular view. That's helpful. And then we can select specific or discrete columns, right? Select component, current size, min size, max size from $SGA Dynamic Components. Now that doesn't look particularly good, does it? We can make our columns much easier to read by using the column statement in SQL Plus with the format operator. So column component format A15 says resize the component column to 15 alphanumeric characters. And in doing that, that gives a report that's a little bit easier to see. So we can see discrete components in the system global area, what their current size is, their minimum, and their maximum size. Sometimes getting detailed information from SQL Plus is a little bit hairy because, of course, you have to consider the column width, the way your terminal prompt or your command window is set with regard to width, and just getting the report formatted. Sometimes that's some extra work. As far as the program area is concerned, let's do a select name and value from $PGA stat. And we'll filter this by saying where the name is inside max PGA allocated versus total PGA allocated. That'll just give us a quick run of our program global area value. I'll do a host CLS to clear the screen. As far as process structures are concerned, your $session and $process are important system views. We can select program from $session. This is going to give my particular session's information, order by program. And we can do the same thing for process communications. Select program from $process, order by program. And this is where we see a slight difference between Oracle running on Windows versus Oracle running on Linux, Unix, Mac OS X. Those systems will show you just single entries for each of your background processes. But here the way it works in Windows is you have a host process, namely the oracle.exe executable, and in there you wind up seeing contained your various processes. It's just simply how Windows works. Some newcomers to Oracle might pop open the task manager like I'm doing now, navigate to processes, and expect to see each of the Oracle processes show up here specifically, and are kind of confused when they see that that's not the case. You can see I have Oracle in this list. Actually, a few instances like we talked about before. This guy right here is, 10 times bigger than the second instance of oracle.exe. But we wouldn't know. It's not very intuitive to see which specific Oracle background processes are contained within each Oracle exe host process. For that, I would recommend you use a third-party tool. And this kind of third-party tool is available for both Windows, Mac, and Linux Linux. Process Explorer specifically is a Microsoft sysinternals tool available only for Windows. And the reason I like it is that you can go into those container service executables like service host. Notice by hovering over it, I can get a pop-up that tells me specifically which service programs are associated with that host process. For instance, the one I'm hovering over now is managing DHCP client, my TCP/IP NetBIOS helper, and one other. We can apply this similar logic to the Oracle instance. This guy right here looks like is our Oracle instance for ASM, Automatic Storage Management. This other one is for ORCL. Finally, let's have a look at storage structures in Oracle. To begin, I'm going to create a simple object. I'm going to create a table called test table that's going to have one column that uses varchar2, 15 characters in length. And now we're going to query DBA extents, one of the built-in views. We're going to grab table space name, extent ID, bytes, file ID, block ID from DBA underscore extents, where the owner is me, the sys user, and the segment name is the name of the object. You know what segments are, of course. So this tells us exactly where that object is located. More particular information on the data file can be had from $data file. We can run a describe on that. A lot of columns here. Let's just grab a select file number and name from $data file. Now sys is writing to system. Your users will be writing to users. Again, we know that we're using the automatic storage management right now, so don't be put off by these unique identifiers that are appended to those file names. This is all created for us automatically and managed for us automatically by Oracle. And again, we'll need to use the column format command to make this a little bit more readable, but I think we're okay knowing that file number 1 is here and this is its name, file number 2 is that name, etc. So if we want more information on this system data file, we can just sub in that file number. Why don't we run select name from $data file where file number equals, and then we'll be prompted for the file ID. Parameter query. I'll put in value 1, and it comes back with the complete, fully qualified path to that data file. So that's just a little tease to get you started on accessing some of that storage-related metadata. We can get all of those previous numbers and more graphically through the Oracle Enterprise Manager console, but I think it was a useful exercise, our doing this from the command line, just in case you see a question that queries your ability to gather that metadata and you do not have access to the GUI. Database architecture and ASM review. Wow, we covered a lot of ground in this nugget. First, we got you regrounded in some basic vocabulary. We now understand in great detail the difference between the Oracle 11g instance versus the database. Remember, an instance are the background processes and memory structures, whereas the database refers to the physical OS level files. We then got into logical versus physical and discussed what pertains to each, the table space, the segment, the extent, versus, again, the data file, the control file, the online redo log file. We finished with a flourish by considering automatic storage management, or ASM. This is a really important subject for your real-world success. Remember, it doesn't factor in too heavily on your OCP exam, but it, like any of the automatic features in Oracle, should be something that you pay particular attention to, because I'm not going to say Oracle always knows best, but it's about the most self-tuning, self-optimizing, self-managing RDBMS that I've ever worked with, and I've worked with quite a few platforms. I hope that this has been informative for you, and I'd like to thank you for viewing.